Your heart rate doubles, blood pressure surges, your breathing turns rapid and shallow, and a massive dose of chemical stimulants floods your brain. If you saw these vital signs on a hospital monitor, you think the patient was undergoing extreme physiological stress. But they aren't dying. They're experiencing human intimacy. In the 1960s, researchers William Masters and Virginia Johnson brought sex into the laboratory. By monitoring thousands of volunteers, they mapped the mechanics of human sexuality into a chronological 4-part timeline. But that biological clock doesn't always start spontaneously. In 2002, Dr. Rosemary Basson proposed the nonlinear model of sexual response. Her work demonstrated that for many, desire is a responsive loop, triggered by external cues rather than an internal spark. Choosing to engage for the sake of emotional closeness or shared pleasure act as the specific trigger that starts the biological stopwatch. Sexual desire operates through a complex mental feedback loop. Those emotional and psychological conditions have to align before the body's physical machinery can take over. Once that machinery activates, the brain's mesolimbic reward pathways fire up. This floods the nervous system with dopamine, a neurotransmitter responsible for motivation and pleasure. In the male body, testosterone and nitric oxide command the blood vessels to dilate. This causes a rapid increase in blood flow to the genitals, creating an erection. In the female body, estrogen drives a similar process called vasocongestion. Blood swells the clitoris and labia, while the vaginal walls begin producing a lubricating organic liquid. Both sexes then experience a sharp spike in heart rate and breathing. For up to 75% of women and 25% of men, the skin on the torso and chest develops a pinkish vascular reaction known as the sex flush. The first 10 minutes of arousal operates as a rapid vascular hijacking. The body redirects heavy blood flow to highly localized regions to prepare its anatomy for peak physical exertion. That physical exertion soon enters the plateau phase. This is a pressurized biological holding pattern where heart rate and circulation continue to climb and respiration becomes incredibly rapid and shallow. As stimulation increases, both sexes experience myotonia. This is an involuntary, systemic increase in muscle tension that spreads through the thighs, hips, and arms. Anatomical shifts accelerate as the body approaches the brink. In males, the testicles are drawn upward toward the body, and the urethral sphincter contracts to prevent urine from mixing with semen. In females, the tissues of the outer third of the vagina swell and narrow to create an orgasmic platform, while the clitoris becomes hypersensitive and physically retracts under its hood. The nervous system is now pushed to the absolute edge of its capacity. The plateau phase locks the body into a state of maximum tension, setting the stage for an inevitable release. That release is the orgasm. It is a massive systemic event that usually lasts only a few seconds, yet requires total physiological synchronization to execute. This diagram shows what happens inside the brain during climax. The prefrontal cortex, the center of logic and self-awareness, effectively goes dark. At the exact same time, the cerebellum and the nucleus accumbens flare up. As those motor and reward centers fire, they trigger involuntary rhythmic muscle contractions, rippling through the pelvic floor and genitalia in both sexes. Every time those muscles contract, the brain dumps a massive payload of oxytocin, the bonding hormone, directly into the bloodstream. An orgasm is a localized, temporary brain shutdown combined with an explosive chemical reward. It replaces conscious logic with pure sensory experience. Following that peak, the body enters the resolution phase. Blood leaves the genitals, tense muscles finally relax, and your heart rate returns to baseline. This graph tracks post-climax hormone levels, and it reveals a stark biological divide. The blue line representing male prolactin and vasopressin spikes sharply into a zone called the refractory period. This specific hormone spike creates a negative feedback loop, making further climax impossible for a set period. Now, the female response. The purple line tracks female prolactin, which experiences a much more modest bump. By avoiding that red refractory zone, many women can experience intense clitoral hypersensitivity or even multiple orgasms. Notice the green line representing female oxytocin. In women, this hormone stays elevated for up to 30 minutes longer than in men, promoting a prolonged period of relaxation and emotional bonding. The vascular buildup and the neurological peak of sex are largely shared experiences. But the biological aftermath creates two distinct physical and emotional recovery states. The timeline of intimacy is a sequence of biological events that restructures the body from the inside out. This process synchronizes our vascular, nervous, and endocrine systems. As heart rates peak, the stress hormone cortisol drops significantly, physically resetting the nervous system. The lingering after-effects of these hormones serve a specific evolutionary purpose. Long after the physical act, that remaining oxytocin biologically binds us to our partners. Human intimacy uses the body's most intense physical responses to leave behind a neurochemical footprint that outlasts the moment.